Hey, sorry, I don't know what happened there. It's like the everything has just turned off. Hold on, let's just get everything back up and running over here. There we go. Yeah, sorry, I don't know what happened there. It's like my whole laptop just said no, I'm done. And it just shut down or crashed. Okay. Um, let's maybe just get back on track. Sorry about that. Where was I? Right, let's just get the screen up again. Okay, sorry. So I forgot what question we were on. It was we were labeling the parts of the drainage basin, right? I think we had done that. We just finished that. And oh, we were counting the stream order. Yes. Okay, now I remember. Okay, where are we? Gosh, there's so many questions. This is such a long paper. Of course, I feel for the actual students writing it. Like the exhaustion you must feel by the end of this. Oh dear. Okay. No, for a second I thought my computer was doing a thing again, but it looks like it's okay. Oh, please don't die on me. Okay, now we've done that. We are here now. Okay, there we go. 5.3. Let me just get the memo out as well. Okay, well, it's busy loading. Let's get the answers along. So we want to know the stream order at T. Now, what would help is if I were able to write on the actual paper. Obviously, I can't write on this, but you guys can. So I would number them. I would number these to like 1 and 2 over here. Sorry, 1 and 1. And where you've got two of the same stream orders meeting, so stream order 1, stream order 1, they would meet together and they would make stream order 2. Here as well, we have a 1 and a 1 that would merge together and make 2. That's another 1 and a 1, so this is 2. That means that this is a 2, that's a 2, so over here they're meeting, and that's a 3. Okay, so far we're up to 3, and we're still like at the upper course of the river. Okay, so I said that this was 2, and it's still 2 because that's a 1, so it stays a 2. This is a 1, so it's staying a 2, and it's joining at the 3, so it's a 3. Okay, is a 1 and a 1, so this stays a 3. So 3. Okay, let's see. 1, 1, and 2, so this stays 3. There stays 3. Okay, we've got a few over here. Let's check these. 1, 1, 2. 1, so this stays 2 and this stays 3. Okay. So the stays 3. Let's check these. 1, 1, 2. And joins over here is 3. Still 3. Okay. Hello. Welcome to the chat. Nice to meet you. Okay. I think here it's going to change things up a little bit. Sorry about that. Should have muted that earlier. Okay, here I think is going to change things up a little bit. So we have a 1 and a 1, and that joins to make a 2, and it stays 2 for this whole section. But here, again, 1 and a 1, so this is a 2. Does that count? Does that count? Is it 1? Probably. So 2 and 2. So then I think this would be a 3. Okay, even if this wasn't a 3, this would at least be a 2 and a 2. Oh, thank you for joining. I really appreciate it. It's nice to have another member. Okay, so we have a 2 and a 2, which means that this will be a 3. That is a 3. So where they merge, we have stream level or stream order 4. Ah, we finally got there. It really is easier if you guys write on the page, like actually number it as you go. Okay, 4. Explain the relationship between stream order and size of the drainage basin. So usually where you have a large drainage basin, you will have more tributaries and you would likely have a higher stream order. Okay, let's see. See if we're right. Oh my goodness, I have to go all the way to the right answers now. Please don't die again. I'm so worried that my laptop is gonna crash again. Please don't crash again. Okay, moving past the essay again. I'm from South Africa. Yeah. Where are you from? Mm. Oh, did I skip the answers? Oh, sorry, I was skipping to the answers. Oopsie. Okay, so the relationship between the drainage size or the basin size and the river or the drainage stream order would then be the bigger the drainage basin, the higher the stream order. So that's what we can see that. So the larger the drainage basin, the higher stream order. Drainage basin is directly proportional to stream order. So this is all just different ways of saying the same thing. Okay, hopefully we've got that. Yeah, I'm from South Africa. We're learning about geography. We're getting ready for the exam tomorrow, for the matric exam. Um, I'm not sure why your messages aren't popping through. Hmm. Okay. Sorry, let me just figure out what's going on over here. No, don't do that. Okay, no, that's fine. Oh, country in Middle East, that's cool. Okay, explain. Wait, no, we've done that one already. The Vaal River is superimposed. Explain what is meant by the statement. Okay, a superimposed river. I'm wondering if I should try and explain what I call the new rule. Um, hmm. Okay, let me just give me a second. I just want to get a whiteboard up. What did I usually use? Was a Jamboard? Um, is it whiteboard? I'm just trying to see if this is what I normally use. I have forgotten which whiteboard I usually use. Okay, is this it? Yes, here is my whiteboard. Oh, no, go away. Go away. Okay, okay, let's just um have they changed the things? I, I just want to make a new one. Yeah, a new fig jam. From Persia. Amazing. That's cool. Okay, where is my stylus? Here it is. Great. So I'm going to try and just explain what I call the new rule. I say it's the new rule because I made it up, so it's new, and also the term new is important. Okay, so oh, new. This is really bad. Okay, but it will make sense in a minute. Studying geology. Okay, I'm actually not studying either one. I'm a teacher. So we're learning geography because the matrics are writing their geography exam tomorrow. So that's why I'm just helping everyone study. South Africa actually has, what is it, 11 official languages, or is it 12 now? I have forgotten. So English is one of our official languages. Okay, so the new rule, we have superimposed rivers and we have antecedent rivers. If we look at a superimposed river, starting with an S, the new thing in this story is the river. So let me grab my highlighter. The S is the stream. Okay, that's the new thing. Then the other one, antecedent, A, right? Okay, the new thing is the mountain or the geology, the geology. Oh, sorry, I thought that was my highlighter. Okay, so if we can kind of picture this as a mountain, there, like a nice little snowy peak. Okay, so S for stream, the new feature is the stream. S is superimposed. A, like it's drawing a mountain. The new thing is the mountain. It's the geography, so the topography. Hopefully that makes sense because now that we go back to what is superimposed, it means that the stream is new. Okay, bear with me. So the stream is new. Um, the river is superimposed. Explain what is meant by the statement. It means that the geology already existed. So there was already land features and mountains, and all of that was already established. And the river formed over the existing geology. So the stream or the river is new or younger than the mountain and the geology. I hope that made sense. So let's take a look at their answer. Okay, superimposed drainage system is one where the river's course and patterns have been superimposed onto the underlying rock structure, often cutting through resistant geological features that are not initially present in the river's original landscape. Okay, so what that is basically saying is that we had a geological landscape, but the new river formed over it and eroded through that landscape. Does this make sense? Okay, I hope so. I hope this is helping you guys. Okay, catchment and river management. Let's start with what we know. What can we see from this figure? So we have a drainage basin, a river system in the Western Cape, okay, and the fact file about the rainfall in the Western Cape. Okay, why do you think we have a fact file about the rain? Any ideas? Okay, so remember, Western Cape gets different rain to the rest of the country. Western Cape gets winter rain, the rest of the country gets summer rain. So most likely they're just reminding you guys about that. So that's probably why they had the information for Western Cape rain in its own little fact file. Okay, we've got a whole bunch of points. We've got a whole bunch of things. Wait, what are these color bands? These purple and pink. Is this altitude? I think. I think it's altitude because it's purple closer to the river and it's like light pink and peach further away. So I think this is like higher up in the landscape. Oh, thank you. You too. I hope you also have lots of success. Okay, and then we have the river kind of running through the low-lying area. Okay, so I think this is supposed to be altitude. Um, we have some cultivated land, so some greenery over there, over here as well. Okay, by the little green spots, more green, and then the gray little squares, that is residential area. Okay, that's developed. And then some other water sources. Okay. A lot of vegetation along this side. Okay, but that makes sense because this is the north facing slope. So that does actually make sense. Okay, in which direction is the river flowing? Okay, so the tributaries kind of point towards that direction. This way is north, so a northwest direction. Hey, thank you. Northwest, do we agree? I think. Let's see. Oopsie, whoopsie. No, 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 don't look at the answers. Don't look at the answers. Northwest, yay! All right, it was multiple choice. I could have actually looked at that as well. Identify the drainage pattern. Tick the correct answer. Okay, radial would be a round pattern, and this definitely was not round. Trellis. I always think of like trellis. So trellis is like you have these lines. Okay, I can't think of a decent way to explain trellis. This is bad. You have almost like these parallel lines that join. Okay, I'm gonna stop. Dendritic, so dendritic looks like a tree, and rectangular looks like a rectangle. Um, and you probably already saw the answer on the memo, so you know that this is trellis. So we have these individual lines of tributaries joining along the main one. Okay, so trellis. So dendritic would be more like a tree shape where they kind of join together in like multiple branches as it moves down, what we saw in the previous one. Rectangular, you kind of have all of these like right angle convergence. And what was the last one? Radial. So it would be joining into the middle. I'm trying to remember. Yeah, centripetal flowing outwards and then radial, but it would be circular. It would have a very obvious middle. Okay, drainage density is, tick the correct answer. High, low, very high, medium. I don't think so. Drainage density is the length of the river divided by the area of the drainage basin. And for lack of a better word, there doesn't seem to be a lot of river, if that makes sense. Like there are a lot of areas without any type of tributaries or channels or anything depicting river. So I would think low drainage density. There is not much happening in terms of number of channels and number of tributaries or rivers. So I'm thinking low. What do you guys think? Okay, we have a high, a low, a very high, and a medium. I'm gonna go low. Oops, sorry, I keep skipping to the next answer. Okay, low. Good. Good. Um, discuss two factors evident in the image which influence the rate of infiltration during the floods in the Western Cape. Okay. Where was this alleged fact file that I was supposed to be looking at? I actually didn't look. Um, where was the fact file? I'm sure. Study figure 12, a river system, and the fact file about the rainfall. Did I miss something? Oops. Did I miss something? Did I skip something? Let me just maybe go back. No, I don't see anything there. I try to do every week, but I haven't been able to lately. I'm gonna try and do more regular streams now though. Okay, I'm missing something. It said that there was a fact file. You know what? It's probably in the beginning. I don't know. Maybe it was at the start of the exam. I probably missed that. Okay, but I think we know enough about rainfall in the Western Cape to be able to answer this. Discuss two factors evident in the image which influences the rate of infiltration during the floods in the Western Cape. Okay, things that would impact infiltration. Let's have a look. Okay, let's start with the gradient. So it does look like we have fairly steep valley sides. I don't know if you guys agree. It looks like it's fairly steep. So steep gradient would imply that we have faster surface runoff and less infiltration, so more flooding. Hmm. Let me just okay. Oh no, I actually can't do that. Let me just try. Sorry. I don't want to keep scrolling up and down to the picture. I want to actually see the picture and the question at the same time. I know in the exam room you guys are like busy paging back and forth to look at the two things. Back here, right? No, further. Yeah. Yeah. Two factors evident in the image would influence the rate of infiltration. Okay, so they're just saying influence, they're not necessarily saying if it increases or decreases. Okay, we have a lot of vegetation. A lot of vegetation. We have all of these. This is the plantation over here. Yeah, we have plantation along the side or along the yeah, either side of the river. Same thing over here. Orchard vineyards. We have reservoirs, so we have a lot of vegetation, we have a lot of agriculture happening, and that would probably reduce surface runoff. So the vegetation would take up a lot of the water, and the roots of the actual plants would also slow down the water from flowing towards the river. There are not a lot of tributaries, so to me, that says that there's less actual surface runoff. Um, what else am I missing? We have a dam over there. Okay, the dam could control the water flow. So if there was heavy surface runoff upstream, that could control or reduce the chance of flooding downstream. And there are some residential areas down here, but that's sort of very flat land. It would increase the chance of flooding further down because it's flat and because it's developed, so less infiltration. No, no. Okay, no, I'm going to take that one back. Okay, it doesn't really seem like the question is saying, is it likely to be high or low? Um, oh yeah, these would also control the flow of these tributaries. You see the weirds, I forgot how you pronounce them. But these are like mini dams that would control how much water comes from each of these channels and tributaries into the main river. So that could actually imply that they have a lot of flooding if they have these flood management systems, but it would then reduce the chance of a flood. Okay, I guess you could argue that in either direction. Let's see what the memo says. No, went too far again. The gradient of the land is higher in the upper reaches. The trailer drainage basin funnels the water into the urban space. Okay, so it's very directly towards the urban or residential area. The steep gradient, like I mentioned, the valley means faster surface runoff, so likely flood. Um, Underlying geology will influence how permeable the surface would be. Okay, yes, it would, but we can't necessarily see what the underlying geology is. Oops, sorry. I'm going to do that. Okay. So we can't actually see what the geology is. If it is impermeable, then the water will just run off of it. If it is permeable, then it's more likely to infiltrate. Vegetation, definitely high vegetation that we could see. So we could see that there was a lot of like farmland and they said forests. Oh, there, forests and woodlands. Okay, yes. So that's right there. But the other areas as well, the plantation, the orchards, the vineyards, all of that, a lot of vegetation. Okay. Must link to infiltration. One mark for listing. Please don't list. If it's discuss or explain or any of that, please don't list. Mention cultivated land, mention the orchards and the vineyards. Okay, I think we actually covered all of our bases there. So that's good. Identify two flood management systems evidence. So those are the two that are actually noticed earlier. The, again, I hope I'm pronouncing this. Oh, wait. I'm going the wrong way. The dam that's there that can control the flow of the river, and the Weirs over here. I don't know if I'm pronouncing that correctly. um, Not the reservoirs. The reservoirs would no. Okay, those two. Oh, they did accept reservoirs as well. Okay, cool. Explain how one of the methods mentioned would influence the flooding of the valley. I think the easiest to explain there is the dam. So the dam can control the flow of the water. So if you have a lot of water behind the dam, the wall would literally hold the water back and reduce the chance of a flood. And the the dam can release some of the water when it's needed and then keep that river flowing during dry seasons as well. Okay, yeah. All talking about managing the flow, prevents sudden flooding, stores large volumes, releases it slowly. Okay, great. So we seem to have that. Ah, explain how the following geospatial tools slash processing can be used to reduce the impact of flooding on communities in this area. Okay, when we look at this geospatial stuff, especially remote sensing, I want you to almost mentally replace remote sensing with satellite images. So, how would satellite images help us reduce the impact of a flood? Um, Assuming the flood has already happened, we can maybe map the areas that have been flooded. Maybe we can establish transport routes. We can figure out where the low-lying areas are. We can see where the areas are most likely to flood and maybe evacuate people from those areas and move them towards higher lying areas. We can also use satellite imagery to see where the transport routes are. So we can see have sorry, this is a dog barking in the background. Have certain roads maybe been flooded? Can emergency services use those roads? Where is the most damage? Where do you need the most relief? So really, it's anything that you can think satellite images would be useful for. And bearing in mind, satellite imagery and all of this geospatial tools and technology that can be constantly updated. So you can have a constant supply of information and you know updates, as it's happening. Um, Buffering would be very useful for establishing the flood zones. So if we look here, we can see where all the low-lying area is, and we could say, okay, it would probably flood to a certain area or to a certain distance from either side of the river. So maybe preparing that area beforehand, maybe evacuating people or not even developing there. Yeah, that, but that's more preventative than after the fact. Okay, let's see what they say. Okay, so remote sensing, aerial images to track the weather, water levels to predict the flood. Okay, so I was assuming that the flood had already happened. So this was more like this one. Um, but yes, obviously you can use it to predict and early warning systems as well because we use GIS and that type of mapping to predict things like a mid-latitude cyclone or a cut-off low or those types of things and say, okay, there's very heavy rain coming in, we are most likely going to have a flood, so maybe evacuate. After the flood, remote sensing can provide detailed images, assess damage, um, plan emergency response, recovery efforts. So very much like what I was saying. Okay, and then buffering. Yeah, establishing where places are most likely to be flooded and maybe just avoiding those areas. So don't construct in those areas and maybe have like some type of flood control method. So like building up levees or, channel walls or something else like that. Um, oh, that's literally what I just said. Sometimes I must just finish reading the answer before I just keep talking. Buffers help design infrastructure to manage floods better. For example, buffer zones around flood-prone areas, better absorption of excess water. Okay, I think we have an understanding of that, hopefully. Oh, my coffee's gone cold. That's sad. Okay, I don't want to do settlements because, like I say, for the CAPS curriculum, you guys are mostly writing on physical geography, so atmospheric and fluvial. Um, yeah, unless there's maybe like a particular question that you want me to go over. Okay. Would you like me to look at a few questions from from last year's CAPS exam? I do have that a couple saved. We do have a minute, so I could take a look. I hope this is actually helping you guys. Um, so these are IEB exams. I go to these ones. Yeah, it's last year's paper. November. Here's paper one. I don't know why this isn't working. Hmm. I don't know. Oh, that's the marking guidelines. Here's the actual questions. Okay, let's just see if there's any types of questions that aren't really covering what we've already done. So we've already done a lot. We've looked at urban climates, valley climates, fluvial processes. So looking at a little bit at river rejuvenation, a little bit at, identifying the different features of a river or the different parts of the river. We actually haven't done fluvial features. Now that I'm thinking about it, there weren't any questions in there about fluvial features, so that's interesting. We looked a little bit about floods and catchment management. So let's just see if there's anything in this exam that wasn't already covered in that other paper. Obviously, it's the same stuff being examined. It's the same work, it's just different types of exam papers. So don't panic if you are writing this paper and I've been going through the IEB paper. It's the same work, it's the same material. Okay. Oh, this is actually a nice question. I haven't seen a diagram like that before. That's actually a nice question. You know, the summer versus winter with the high and the low like that. Okay, but I mustn't get distracted because I've done that in a favorite final, so I'm gonna leave this for now. Um, Okay. 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 I'm gonna leave that. Brainstorm. Okay, valley climates. So we've done the valley climates. We have the cold air, cold katabatic, and then the warm air would then be anabatic. Um, so this whole one, are you just matching? Refer to the sketches and answer. Oh, okay, yeah, you're matching which one happens when. So in our previous exam where you had to explain how the frost pocket forms, over here you just have to identify which one would form a frost pocket. Okay. Oh, the pollution dome. Okay, we haven't done this. So I know we did urban climate, but we didn't do anything with the pollution dome. So let's actually do these questions. Refer to sketches A and B on the pollution domes below to answer the questions. So which one? Wait, are they asking which is which? I'm assuming so. Yes. Okay, so which one represents a pollution dome at night? Okay, at night it is cold, cold air sinks. So that would be B. Pollutants are dispersed, so they would have to rise and move away to disperse, so that would be A. And denser concentration of pollutants over the urban area. So dense concentration means that it's all packed into a small little space, so that would have to be B. Let's check the memo. Let's see if we're right. Here it is. 1.2.5. Let's just zoom in so we can read it properly. Okay, so what did I say? I said B, A, and B, right? B, A, B, B, A, B. Yay! We've got this. Okay, refer to the cross section of mid-latitude cyclone. I think we've done a lot of mid-latitude cyclones, so I'm just going to actually skip this section. Just want to get to the stuff that we haven't really covered. Okay, we have a tropical cyclone. Sorry. Tropical cyclone made landfall at that time. Okay. This is the path that it took. So it started, where did it start? Oh, it started here, 10th of March. Okay. It started there. It moved over here. So it moved over Mozambique, deflected back to the ocean there. Okay, there's some information about it, and there is the synoptic weather map image. State one condition that would have led to the development of, oh, tropical cyclones. I think we've also done plenty. Um, I have done a whole favorite final video for tropical cyclones. I think I'm going to leave that one as well. Like all of this is typical questions that you would see, that I think all of these conditions required. Okay, why did it strengthen? Why did it weaken? Draw a cross section. Okay, all of that is stuff that I included in the favorite final. So you can see these questions, they really repeat themselves. Sorry, dog barking in the background. Okay, line thunderstorms. Again, covered this with anticyclones in another favorite final. I'm trying to see if there's any questions that I didn't include. So yes, I answered that one. Yeah. Yeah, I feel like you guys can answer that. And negative impact. Yeah. Yeah. You would be fine with all of those. Okay, geomorphology. Yay, rivers. Match the columns A to the options in B. Oh, there's only two options. This is like a multiple choice with two different options. Well, that's nice. So it's either Y or Z. Um, area drained by a river and its tributaries. Catchment area drainage basin. Okay, you remember what I was saying earlier on that the drainage basin is the whole system? Oh, sorry, just give me 1 second. I will be right. Okay, thank you for waiting for me. Sorry about that interruption. Um, right, so the catchment area, that is the area that literally catches the water or the rain and the everything, and then the drainage basin is the combination of everything. So since they're actually asking the area that is drained by the river and its tributaries, I'm thinking that's drainage basin. Yeah, because catchment area would be referring to the area that catches. Welcome back. Hey, Sergeant Baker, I haven't seen you in ages. How are you? Sorry, your messages aren't popping up in the chat block. I don't know why it's not working. I obviously messed up something in the settings. Um, promotes a rapid rise in the water table. Okay, rapid rise. So water is running quickly, it's flowing quickly. So we need a steep gradient. That would be Z. Upper level of the groundwater, the highest level, so the top of the groundwater, that would be the water table. Seepage of water into the ground. So as it flows into the ground, it is infiltration. Causes reduction of surface runoff. Impermeable rock. So, okay, impermeable rock means that it can't infiltrate. Dense vegetation. Vegetation would slow down the water and give it time to infiltrate. So definitely Z, dense vegetation. The confluence is located at Y or Z? Z, because the confluence is where the two merge. High-lying area separating two tributaries and the same river system. Hmm? Oh, oh, that would have to be, wait, no, wait, high-lying area separating two tributaries in the same river system. So that would be Z, right? I thought they were asking what it's called. Because this looks like it's two different drainage basins. They look like they're going in two different directions. So I don't think that's the same system. Okay, I have forgotten what I said the answers were. Now, how am I going to check? Okay, so it was Z, Z, Y. Let's just take those so far. I forgot I skipped these questions. Okay, Z, oh, Z, Y, Y. Why did I say Z, Z? What? Gentle. What? Promotes a rapid rise in the water table. Okay, once again, I did not learn my own lesson from earlier. Read the questions properly. I just read it as like rapid rise of water. So I was assuming flood. Rapid rise of water table, it means that there's more infiltration. Okay, so we have to have a gentle gradient so that the water can flow slowly, and then we would have a rise in the water table. I'm very disappointed in myself. I did not read the question properly. Okay, so Z, Y, Y, seepage was then Y again. Z. Okay, so Y, Z, Z, Z. Right? Am I getting that right? Okay, let's check. Y, Z, Z, Z. Okay, yes, I got the other ones right. Okay, some redemption, maybe a little bit. It's been a long day. Okay, this is like my second exam that I'm busy doing. No, I'll be honest, I didn't study. I should have studied. Okay, what do we have here? Various options. Okay, more multiple choice. Yay, like multiple choice. Um, questions on fluvial processes and landforms. Okay, I was saying that we didn't have any questions on fluvial landform features yet, so I'm glad that we're finally getting that. What is responsible for the shape of the river valley below? Okay, nice steep-sided valley. So that would definitely be erosion happening at the bottom. So deposition, no. Weathering, no. Weathering is the breaking down of the material. Definitely erosion. Very clever that they have two different options for erosion, lateral and vertical. So lateral means towards the sides, vertical means downwards. Because we have such a steep-sided valley, it's mostly eroding downwards, so vertical. And I love that we've got like a little V for vertical valley. Okay, we have vertical erosion. Let's just double check. D, yes. Yay, we are so clever. Okay, a what forms at the base of a waterfall? Plunge pool. Okay, that one we just actually have to know. We didn't have anything to work on for that. Okay, at the bottom of the waterfall, we have a plunge pool. D, wait, was that D? Yes, D, yay. The fluvial landform slash feature depicted in the sketch. This looks like a rapid, right? So, again, it's not waterfall because we don't have like a horizontal layer of resistant rock and then the falling water and then the plunge pool at the bottom. But we do have like these layers, this alternating layers of soft and hard rock. So that would have to be rapids. So that is C. Yay! We're getting it. We are ready for our exams. We're going to ace them. Okay, a flat. Sorry, the dog is being demanding. Come inside. Just give me a few more minutes and then I'll come play. Okay. And now I'm play. Come here, though. The dog wants to play. Obviously, he's just had supper and now he's got energy and he wants to play. I'll go play. He keeps scratching on the door. I just want to see if he actually wants to come in. Do you want to come in? I'm not gonna chase you. I'm not gonna chase you, no. Come. Lucky, come. Come here. Lucky. Come. Hop. Come, hop up here. Come. in or out? Let me see if I can buy his love. Go. Yes. No. Okay, you got away. I was trying to bribe him with a treat, but he does not seem to be interested. Oh, sorry. I'm just leaving the door open. Bucky, come in. Don't just keep scratching at the door. Come in. Okay, a flat, low-lying area along the banks of a river in a lower course. That would have to be the floodplain, right? Besides the sides on either side of the river, the flat sides on either side of the river. Why are you running away? Just take the treat. So I'm saying C, floodplain. Yes, floodplain, great. And the slope X on the inner bank of a meander, also referred to as a what slope? A slip-off slope. As I say, it's like a nice smooth slope that you could like use to put a boat into a river. So a slip-off slope. Oh. Where do you keep running off to? Hop. Like, there's a treat. Go jump up and stand up. Yeah, jump. Oh, there you go. There he is. There's the noisy thing. Sweetheart. He keeps running away because he wants me to chase him. He wants to play. I caught you. I caught you. Now you've got to say hello. Okay. So this is where the noise is coming from. Loki, say hi. Yes. Okay. Have a treat. Good boy. Okay. Then you can go. You can leave now. Bye. Bye. Go. 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 Get out of here. I just want to finish these few questions and then I'll go 10 10. Okay, so I said slip off slope. Did we check that answer? Yay, slip off slope. A what forms when a meander loop is cut off from the main stream? That is an oxbow lake. So that would be C. Let's see. Let's see. I'm sorry. That's really bad. The benefit of natural levees is what on the floodplains? Is reduced flooding. Definitely reduced flooding. That, you know, keeps the water like actually in the channel. So B. B, yay! Deltas in the form of the river mouth where, deltas form at the river mouth when the following occurs. Okay, shallow seabed. What? I don't think so. Steep seabed? What? Oh, they're saying that like the river is not very deep. Oh, oh, I think they're implying that the water, the ocean that the river flows into is not very deep. Okay, then I think yes, shallow seabed because then I can deposit the material and it can build up really quickly. So that makes sense. Steep seabed, I don't think so. I think shallow, yes. Strong currents, no, because the currents would probably wash away any deposited material. Small tidal range, yeah. Small tidal range makes sense because then it's not likely to, you know, swash and backwash and flood and move all of the sediment away. So I'm saying I and IV. What is that? 1 and 4, right? So D. D. Yay! We are clever. Okay. Oh, we finally actually have some like written answers. There's not too many questions left, or not too many pages left. I don't see how many. Hmm. Oh, this is all the longer questions over here. Okay, but this is map work. I can't actually help you guys with map work, unfortunately, because I don't have the map. So that I'm afraid I can't. Okay, let me see which of these questions I can help you with. Um, and then we can call it a day over there. Okay, identify drainage pattern A. A. Would this be radial or centripetal? Mm, I'm not sure. I think this is referred to as centripetal, but I might be radial. Now I'm actually not sure. Okay, I'm gonna cheat and I'm gonna look at the answer. You guys okay with that? Okay, radial except centrifugal. So centripetal was wrong altogether. So I only would have gotten the mark if I said radial. Okay. Oh, and now we saw the second as well. I'm assuming that's stream order, right? Determine the stream order of X. Well, this one's much easier to count than the diagram we had earlier. I don't know if you guys agree. Okay, so we have one from there and one from there, and they join together to make it two, so that would be second or two. Give a reason for the direction in which the streams flow in drainage pattern A. Okay, they're all flowing away from the middle, so I'm assuming this is some type of a high-lying area in the middle, so maybe a mountain or a volcano, so something with a peak, and then it flows down either side. Let's see. Radiates outwards from, okay, sorry, you guys can't see that. There we go. Radiates outwards from high-lying central point, except examples of landfall. So mountain and volcano probably would have been accepted. But you first have to explain that it's a high-lying area in the middle. How does the joining of the tributaries to the main stream differ in drainage patterns A and B? Okay, there the main difference would be the angle. So over here, they join at very, gentle angles. So what is that? Acute angles, so small angle. And over here, they join at right angles or almost perpendicular. I hope I have that right. Yes, tributaries join the main river at acute angles at A and right angles at B. State two conditions associated with the underlying rock that contributes to the formation of the trellis drainage pattern in B. There would probably be alternating, so this would probably be quite resistant rock, maybe with certain layers of less resistant rock, possibly cracks or faults. Um, mm. So I'm going to say we've got alternating layers or strata of rock and probably fault lines perpendicular to those main layers, and that would contribute to this. Let's see. Okay, alternating layers. Oh, sorry. Just wait for this to go away. There we go. Alternate layers of hard and soft rocks of varying resistance or folded rocks. Okay, I suppose I could see folded rocks as well. I thought they were wanting to know why is it at right angles, and that would be because of some type of like fractures, or yeah, like fractures coming from those alternating lines. What happened to my camera in there? I don't know. Why are human activities limited in areas where drainage patterns A and B are found? Oh. Hey, welcome. Good to see you again. Why human activities limited? Oh, I don't think it's. Yes, it has been a while. I'm good. I'm good. So we're busy preparing for our exams tomorrow. So tomorrow is the IEB and NSC final, or the CAPS curriculum final matric exams. So just helping everyone get ready for that. I don't think the answer is actually related to the river. I think the answer is related to the topography. I I don't know if maybe I'm reading into it. I hope I'm not reading into it too much. But for this one, for A, we know that this is probably a steep-sided mountain, and you won't really find a lot of development or human activity on a steep-sided mountain. So that's my idea for A. And then for B, we probably have this alternating very hard and soft rock, and that's probably not ideal for agriculture. So, not ideal conditions for development or human activity. Um, that's my guess. That's what I'm going with. Okay, it looks fair. Okay, land is steep or uneven. Okay, it's kind of what I was saying with the mountains. Um, Prone to soil erosion, thin soil, infertile soil. I don't know how they got to infertile soil. Risk of mass movement and high cost of developing land. Hmm. I kind of feel like all of those apply to A, but I don't really see anything relating to B. But it does seem like it's related to the actual topography more than the rivers. So they're talking about the soil, the landscape. Yeah. So it's not really the rivers, it's more what caused the rivers to be this shape and how would that influence human activity? That same cause. Okay. Define the term river rejuvenation. So we had a similar question on the other paper. So this is where a river gets I was gonna say where it gets renewed, but no, where it gets a new bout of energy and water, and it flows faster and it erodes more. It could be for numerous different reasons. I'm sure they're going to ask that in a minute. But basically, where a river gets new energy, it flows faster and it erodes more. Identify the feature at A. That looks like a waterfall. I don't know if you guys agree, but that looks like a waterfall. And how does A indicate that river rejuvenation has taken place? Well, I suppose it is eroding enough. If you look at B, oh, shame, the dog. Sorry, if you can hear the dog, just ignore him. He's being dramatic. If you can see all of that erosion happening at B, the river had to have enough energy for it to erode into the landscape like that, forming the waterfall at A. Describe the change that river rejuvenation has made to the landscape. I'm sorry. Really? Are we doing this again? He's coming back. Just wait. Just wait. He's coming back. Don't worry, the dog wasn't being tortured or anything. He just knows how to manipulate us. And he's often very dramatic and vocal when he's not getting his way. Okay, fine. Go cry at the door. Describe the change that river rejuvenation has made to. Just wait. To the landscape at B. So the extra energy means more erosion. So it eroded deeper into the landscape. And that's why we have this valley in a valley. How do river terraces form? So this is very much like what I was just saying about the. Sorry, I just want to actually see if what I've said so far is right. Okay, river experiences more energy, right? That's the definition of rejuvenation. Oh, make a point except waterfall. Oh, okay, I said waterfall. Oh. Change drop in gradient, evidence of vertical erosion, right? So the river was flowing faster, more erosion, hence that downward drop. And then, where was it? Was it 4.4? How the river rejuvenation formed landscape B. So the extra energy, downward erosion, and we have the valley and valley. How do river terraces form? That would, I suppose, be repeated rejuvenation. So you have the erosion forming this one layer, then maybe the river loses some of its energy. If it gets rejuvenated, it will erode down again and will almost be like steps. Okay, vertical erosion during the flood. A new river. Okay, sorry. Okay. A new river valley is formed. This creates a step-like feature known as a terrace. The old floodplain is now in the river. Okay, so this is like we were saying, we had erosion happening, then we maybe have rejuvenation, new erosion vertically, so deeper into the valley, and you have like these steps. Why are some river terracing not suitable for farming? I'd say maybe it's too steep, maybe there's not enough space, maybe it's difficult to get transport onto or off of. It's very difficult to build up roads. Far from water source, I suppose. I mean, to be fair, it's next to a river, but I suppose it's like above the river, so not really on a floodplain. I can see that. Difficult to build there, right? The terrace could be narrow, absolutely. Limited use of machinery. I feel like you would need to explain that a little bit more. Maybe like limited access, especially with transport, down this kind of weird stepped landscape. Decrease in soil fertility and thin soils, I suppose with the erosion washing the soil away, and uneven landscape. Absolutely. It's much easier to farm on flat, larger landscapes. Okay. I'm wondering if we have time for 2.5 or if we should just call it there. Okay, no, most of this seems to be relating to this. Okay, well then I think let's wrap up over there. Thank you for joining and thank you for the patience with the noisy dog in the background. I really hope that this has helped and I really hope that you guys are feeling a little bit more prepared for the exams tomorrow. Yeah, I I wish you guys lots of luck and we'll see if maybe closer towards paper two, if you guys need another one of these let studies focusing on the human geography, I suppose we can do something like that as well. But we'll see. Okay. At the very least, I'll try and do a few more favorite finals looking at human geography. So settlements, economy, and that kind of stuff. Otherwise, good luck. Study hard. You are almost at the end. I know for matric exams, this feels like make or break. You've got a whole lot riding on your shoulders right now, but you guys would do great. I have no doubt about that. Okay. Have a lovely day and a lovely evening further, and best of luck. Hopefully, I see you guys again. Okay. Cheers. Bye.